Basically, a star is a giant recycling system which also dissipates the energy of galaxy birth. The sun is a giant hollow shell of plasma. These are the solar granules that are on the surface, and this is where the majority of the chemical reactions occur. A lot of the magnetic fields in the star are in the surface, okay? Plasma is very violent, unruly. It just does whatever it wants. It forms sunspots and creates these giant magnetic fields that loop around inside the surface of the star only. These very, very large, very thin granule bubbles provide the sun its internal structure. As well, the majority of the heat from the surface, okay, is on the surface. And these convective bubbles protect any extra incoming heat from going towards the center. So what you have here is a cold interior. Not many chemical reactions are occurring here. The most violent ones are obviously at the surface, but when those reactions happen, they drop down because they're heavy. And they start raining down through these convective walls and depositing towards the center. And as this material moves towards the center, the shell contracts. And then you have magnetic fields. They start reaching, start touching in the center, and aligning a lot of the material. Stars are vacuum in their interior, and over time, the star forms what we call an iron-nickel core as it evolves. And that iron-nickel core is pretty well pure. It's not something that is full of contaminants, and there's clearly some type of control mechanism allowing just the iron and nickel to clump in there together without any other elements. It starts forming the core and layering it like a giant pearl in thin little slices over very large amounts of time. And now the center core starts controlling the magnetic field and making it as a global magnetic field instead of all over the place. As it reaches red dwarf stages, it will begin flaring more, and they call these flare stars. And over many more millions of years, that outer atmosphere diminishes even more, and you have a brown dwarf. And as you'll notice, it keeps its iron-nickel core, and obviously the other elements will layer on top of that. What we have here is a hot Jupiter. Now the hot Jupiter becomes something like a Neptune or Uranus. And then over even more time, it just keeps its core in its leftover atmosphere. The star will sustain its magnetic field as it evolves, and the retentivity diminishes, and eventually even many more millions of years from asteroid impacts and things like that, the surface gets ripped away and its atmosphere dissipates and it becomes something like Mercury. So what we have here is a core formation in form of vacuum vapor deposition. This doesn't exist anywhere on the internet. I guarantee you that.